In this video, we're going to cover the product rule for derivatives. Now, keep in mind that we have a couple of rules for taking derivatives as it is right now, but the product rule allows us to take two functions, say f of x and g of x, and multiply those two functions together where I can take the derivative of them. Now keep in mind that, again, this notation right here stands for the derivative of all of this. So, another way that you can see this specific method or form is by taking the derivative in this form as well. Again, recall that d dx stands for the derivative of this entire function in respect to the variable x. Now, in a separate video, we'll go ahead and prove how this derivative comes about, but the derivative of the multiplication of two different functions will be the derivative of the first times the second unchanged plus the derivative of the second times the first unchanged. Now, again, one more time, the derivative of two functions multiplied together is the derivative of the first times the second plus the derivative of the second times the first. This is the formula. Now these x's might get a little bit convoluted in the way, so what I'll do is I'll abbreviate this so that the derivative of f times g is the same thing as f prime times g plus g prime times f. So now let's avoid this formula setup anymore, and let's actually look at an example. The first example we're going to take a look at is something that, again, might be easy for us to take derivatives of, but more complicated in terms of setting up. So let's just call this, and now I'm going to do this in such a confusing way that we make sure we don't mess up anything. I'm going to call this function f of x. This function is 3x squared plus 4x minus 2 times 9x cubed plus 2x plus 1. So, this is the multiplication of two different looking things. It is very clearly that they're multiplied. Now, could we actually take the derivative of this without having to use the product rule? And the answer is yes. If you're so inclined to take 3x squared and distribute it to all three terms, and then 4x and distribute it to all three terms, and then minus 2 to distribute to all three terms, then combine up all your like terms. You should have a total of 9 terms when multiplying out, but you'll end up with probably less after combining like terms. But this is not something we're going to want to have to do. There's a lot of chances of making algebraic mistakes, so what we're going to do instead is use this particular product rule. So, what I'm going to do is my function starts out as f of x. I'm going to use this notation here, in which cases I'm going to call the first function f, I'm going to call the second function g. Now off to the side here, again, because this is nothing more than a formula, I'm going to write down f. F is 3x squared plus 4x minus 2. I'm going to go ahead and write down f prime. Now, if we recall, the derivative of any algebraic term is I'm going to carry down the power and multiply, and then subtract 1 from the power. So, carry down the 2. 3 times 2 is 6. And subtract 1 from the power, I use x equals x to the power of 1. Then the derivative of 4x is nothing more than just 4. Don't forget you also have the rule for g. So, g is going to be this function over here, and g is 9x cubed plus 2x plus 1, where g prime is going to be equal to the derivative of this term here. 3 carries down, 9 times 3 is 27, subtract 1 from the power, x to the power of 2. Derivative of 2x is just a positive 2. The derivative of a constant is always 0. So now I have f prime, I have g, and I have g prime. And if I want to know what is the derivative of this original function, again, this original function is f of x, these f prime, g, and g prime are just placeholder names. Okay, the derivative of f times g, the first times the second, is the derivative of the first. So down here you'll notice f prime is 6x plus 4. So I'm going to write that down, 6x plus 4. That's the derivative of the first piece, times the second piece left unchanged, which, if you'll notice here, is g, is this. So in parentheses, 9x cubed plus 2x plus 1. So there is the first pieces, f prime times g. Don't forget your plus sign, and I have to multiply that by g prime f. Now if you'll notice, if you write the manipulations out this way every time, those two things multiplied together provide you with your first thing, plus, and then we're going to go ahead and take this f and multiply it by the g prime, and that will give me my second thing. So, to follow the formula, g prime is 27x squared plus 2, in parentheses, 27x squared plus 2, and your parenthesis, and then times f. F being, again, 3x squared plus 4x minus 2. This provides us with the derivative of f. this original function. And that would be our final result unless we were told that we had to simplify this function. In some cases you will have to simplify this, in which case you'll have to distribute the 6x and the 4 to these three terms and the 27x squared plus 2 to these three terms and combine like terms, but in this case we're just going to leave it here. That right there is the basic version of the product rule.